We have workshop slides, and this is what I'm going to use. Because it may make a lot of sense to copy and paste from these slides, because there's a lot of source code ready to use in this. Okay, then what I recommend is to download these slides, because if you use the viewer, a slide viewer built in Box, copy and paste won't work. Okay, so I'm starting PowerPoint. OpenGL primer, a quick guide to start programming. So our goal, the first goal today, will be to render a triangle. These slides are thought to be a guide, so usually I have a slide with the code and a number of slides followed by a number of slides with precise explanations, okay, what each piece of this code is doing for you. I will use these slides in a little bit different way. So I will, from time to time, I will show you a slide or two, okay? But basically, I will keep these slides in the second window. What I will do now, the first slide in the workshop presentation is entitled Render Triangle. And it contains the code of the render function, okay? So what I did and what I recommend to you as well is just to use the copy and paste functionality and copy this code directly to your code. And now please pay attention to what I'm going to tell you about this code, because not everything. Actually, just a few of these instructions, but some of these instructions we will be using for the remainder of this academic year. Okay, so it would be really good for you to know what they are doing. So first of all, function render, it won't be called. Okay, so it's not yet a working OpenGL application. I'm not even sure it should build. Yes, it builds, but the function render will never be called because the main function looks like this. All right. Also, I recommend to copy in all the stuff, all these functions above the main function, so that the main function is the last in your code. Or otherwise, you can turn to the instruction sheet, which is this one, and here you have a general structure of the application that you are writing. So you have to include GLUT, and then I will be creating 4 different functions: init, render, reshape, and main. You should have a short version of main already, and now we are doing render. Now, the render function, as the name suggests, is for rendering graphics. When we are finished with this sample program, the render function will be called many times per second. If you participated in game science module last year, you remember a GFC, and we had a function like on update, on draw. They were also called many times per second, once per frame. Okay, so this is a once per frame render function. And what's inside? So the first instruction is GL clear color. GL clear color specifies what's the blank color, what's the background color of the screen. Actually, you might want to move this function to this call to the init function, because once you set up the deep gray background, you are probably happy with this, and you don't have to set up this clear color in every render cycle. I was about to change it, I forgot, okay? But it also works here, so no problem. Then we have GL clear. GL clear is a function to clear the screen, right? We have to draw entire frame, so we have to start with a clear screen, and clear screen is the screen filled with the color specified here as the clear color. So the first two instructions make the screen clear. We will clear two different buffers, and you don't have now to yet to know what a buffer is, okay? Because we will be talking a lot about buffers, but from I think from the next week. Basically, the color buffer is the screen, and the depth buffer is the depth information used in generating 3D graphics. Then a few instructions to set up the viewpoint. So first of all, we will tell the system, tell OpenGL that we are in so-called model view mode. Model view means that we'll set up models, 3D models in the scene, and we'll set up the view. So where is the viewpoint or the camera, virtual camera looking at the 3D scene. We'll also load an identity, so it's like resetting all the transformations, so going to a default state. And we set up a so-called a matrix. Never mind, you don't have yet to know what is a matrix. We'll set up the camera in that way, how to understand it, that the camera is positioned at the coordinate 0010. It's looking at the position 000. And also it has so-called up vector, 010 up vector, means that if you have a camera like this, sorry, people connecting remotely cannot see it, but I'm right now keeping my handling a camera in front of me. Okay, the up vector is a vertical vector above the camera, which you can use to tilt the camera in a funny way. Okay, but 010 means this is a vertical vector, so the camera will not be tilted in any way. This is the default value. All right, then we have an instruction informing OpenGL that we want to start drawing triangles. And it's called GL begin, GL triangles. Begin means, okay, we'll now start drawing with something, and this something that we are going to draw are triangles. And we will also send 3 vertices. Vertex is a point in the 3D space. So to set up a vertex, you just need to send 3 coordinates. And these 3 coordinates hopefully will create one triangle. And when we are ready with sending 3 coordinates to create a triangle, we also say GL and then GLUT swap buffers. GLUT swap buffers is a very important instruction because this means that, okay, I have prepared the buffer of data. Now the system can display it. OpenGL, like most other systems, use the double buffering technique. So whilst we are drawing the 3D scene, there's another, the previous version of this screen in a different buffer used to display and maintain the image on your screen. Okay. Now, whilst this second buffer, the back buffer, is sorry, the front buffer. The front buffer is used to display the on the screen. You draw in your back buffer, and when you are ready, you just swap these buffers. So the front buffer becomes the back buffer becomes the front buffer. You now can draw in what was previously the front buffer, and what previously was your back buffer will be now displayed. This means that you can create your scene gradually, and no of your drawing functions would be visible on screen before you are ready with this buffer, and you say GL swap buffers. Okay. Without double buffering, displaying graphics would be very flickery and not very nice. Okay. Now, a few observations from this code. As you can see, everything in this short function starts with the letters GL. GL stands for graphics library, and it's a standard prefix for everything OpenGL. If this prefix is just GL, like GL matrix mode, this means that this is a part of the main part of OpenGL. And if it has, like in this case, it's just swap buffers. If it starts with the word GLUT, this means that this is a function from the GLUT library. What is the GLUT library? The GLUT library are these 3 files that you had to download from the assets. And now as an explanation, you may have noticed it doesn't ask you to install OpenGL. In a way, this is a great simplification, but in a way, OpenGL is installed by default in every system, in every Windows machine. Okay, so you don't have to specifically install OpenGL. Next week, we will discuss OpenGL in detail, and I will tell you exactly where installation of OpenGL is in your computer. I can actually tell you now. It's in your graphics card drivers. Okay, so if you have a graphics card and this graphics card is properly installed and you have the up-to-date version of your graphics card drivers, you will have an up-to-date version of OpenGL. That's as simple as that. But I also told you today that OpenGL does not provide any support for the Windows, for keyboard, for mouse. You need something else for this. And the something else is the GLUT, GL or Graphics Library Utility Toolkit. So we need an extra utility toolkit in order to open the window, use the keyboard, use the mouse, okay? But everything graphics related to graphics is provided by OpenGL itself. And the second important thing, this is a sentence that will be repeated in this module so many times, and tada, this is the first time. OpenGL is a state machine. This means that if you set up something in OpenGL, it will remember about it until the moment when you set up this thing in a different way. So, for example, if you call the GLUT function, you set up the position of your camera, and it will be stored in the system until the moment you decide to change the position of the camera. It will just be stored there. If you say, okay, we begin drawing with triangles, OpenGL will be in state of drawing with triangles until you tell GLN, we finish drawing with triangles, okay? So many things in OpenGL will require you to start something and finish something, or set up something, and if you want to change it, you have to send another setup function, okay? So that's the general idea of programming in OpenGL. These lines here are everything that you need to draw a triangle. Please note, if you know anything about OpenGL, you will probably notice that this code is absolutely terrible. And this is really not how you are supposed to program in OpenGL. But we have to get to the proper way gradually. Okay. Most of these functions that on the screen right now are deprecated, so shouldn't be used. But it's impossible to create a really short example in OpenGL without using deprecated or outdated functionality. So today we don't worry, okay? Today we go a little bit outdated, but at least we will have something working at the end of the session. So this was a render. Next thing, our slides provide you some information about context of the application. So a number of technologies that you can actually use, like a direct Windows API, which is not the best solution, like also SDL. SDL is something that we've been using as a lower layer in GFC. GLUT or FreeGLUT, that's what we are using. And GLFW, that's another Windows-specific library. We're using GLUT. And what is GLUT? GLUT is OpenGL utility toolkit, originally written for Unix, then ported to Windows and MacOS. So this means that it is nicely portable, and it supports interaction with the Windows system, input, output, simple pop-up menus, fonts, and stuff like this. All right. Now, we need more to get our OpenGL program running. And if you think that I'm introducing this stuff too slow, you can be faster. You can just use these slides. What you need is to eventually have the main function. Apart from the render, you also need the main function, the init function, and the reshape function. Okay. All right. So I've just copied in the actual main function. And this main function has a few obligatory parts. So first of all, GLUT init. GLUT init is something that you have to call in order to use GLUT. And it takes standard C parameters like argc, argv. Okay, it's just a standard call. You will never ever want to change it. So it's what we have put here today. We'll be happy with this until May or the end of the year. Okay. Then we have to initialize the display mode. We will initialize this with some options. And do you remember our classes about bitwise logic in the beginning of the first year game science? We use bitwise logic here because these three names here, GLUT depth, GLUT double, and GLUT RGBA, are binary coded options. So for example, the value for GLUT RGBA is the same as GLUT RGB, that's 0, actually. Yeah, but for example, GLUT depth is 16, so this is the bit 4. GLUT stencil is 32, bit 5, and so on. So you can set up several different options. You can choose and pick whatever you need, because each option is a combination of bits. So this works if you want to set something, an option in the GLUT display mode. You have to send a word that would have the particular bit switched on. So this means something like that: GLUT depth, bitwise or GLUT double, bitwise or GLUT RGBA. So we switch on depth test. Depth test is that if you have an object, okay, that's a live demonstration. I don't have a camera with me today, but I'm having my teapot in front of me, and I'm taking the cover of this teapot in front of this teapot to show you how hidden surfaces work. Okay, to have a hidden surfaces, so a feature in a 3D scene that one object can obstruct the view of another object, requires you to enable the depth, including depth buffer. GLUT double means double buffering, something that I've just explained how it works. And GLUT RGBA means that we will be working in RGBA color space, which is a standard thing today. Okay, RGBA stands for red, green, blue, alpha. Alpha is transparency. Then init window position. We just tell the GLUT system a window at the position 100 by 100 and the size 800 by 600. Feel free to change these dimensions if you feel that this window is too small for you. And we create window. We create the window with a title, CI 5520 3D Graphics Programming. Sorry, the title is outdated. It should be now CI 5525 3D Graphics Programming and Artificial Intelligence. Then we register two callbacks. You can notice that there is a callback called render, and there is another callback called reshape. We've already created render, okay? So this registering callbacks will make our GLUT to call the render function each time the graphic should be rendered. And we will also need the reshape function, about which I will tell you in a moment. Then init, light, and everything, not a GLUT or callback function. This is our function init. So any one-time, one-off initialization. And then GLUT main loop. GLUT main loop is the function that will be executed for the entire life cycle of the application. So after initialization, we just go into GLUT main loop, and it will control the application until you click, press Alt F4 to finish the application. It won't build now, but I could comment out the reshape and init temporarily, because we will need these functions definitely. And you can see for the first time we have got a graphical window. So that's the window in which everything will happen. Okay, we can't see the triangle yet, only because we are missing some essential initialization. So let's go to the essential initialization. Uncomment. Okay, a few words about the structure of the program. You can structure your program in this way as well. So you can start with the main function in the top, followed by init, render, and reshape. But if you decide to structure like this, you need to provide prototypes of these functions, otherwise they will not be visible. A prototype is a short declaration. It's like saying, hey, compiler, I will be using a void init function, okay? So if you find a function called to init, don't be surprised. This is something I want to use. This is how it is going to look like. And yeah, I will define it later, okay? And then the compiler says, all right, I'm happy with this. But I expect that by the time the program is linked, the definition of this function will be somewhere to locate. If it is not, you will have a linking error. When it is, if it is, everything is okay. If you omit or if you miss these three prototypes, and for example, call the init function from within the main function, so this function from here, the compiler will say, hey, seriously, what WTF? I don't know what init is. WTF stands for what a terrible failure, okay? So WTF, you've forgotten to define or declare the init function, okay? So in the programming terminology, if you provide the full code for a function, that's a function definition. If you just provide one line to say, that's how it's going to look like, it's a declaration, okay? But I'm using in the Visual Studio, which is under the slide somewhere, I'm using a structure in which I first define all the functions and then use them, so I don't need prototypes. Okay, the init function. The init function right now has only 4 simple calls. The first one enables the depth test, necessary for most 3D applications, and enables automatic normalization. It will be needed by some libraries we'll be using later. Today it doesn't matter actually. It also switches on the shading model to smooth or ground shading. And that's the reason why I would like you to watch the first 3D lecture at some point in the future to understand what the ground shading model really is. Okay, but no need to know this now. I will just tell you things look better in the smooth shading model. And we also have a polygon mode, just the default one, but you can also try GL line. Okay, so some stuff. So what I will do, I will just copy and paste this init function. It's init, so it should be close to the top. Okay, init is pasted. And now we are just one function away. This one function is called reshape. I will tell you what reshape does in a moment. firstly, I would like to see something working. So I will just copy and paste the reshape somewhere here. Build and run the code, and yes, we have something. We have just rendered a three-dimensional triangle, a single triangle. Success. This actually finishes my role today, because what I wanted to do was to show you how to render a triangle. Okay, so I've done my work in Visual Studio, and before I finish and get completely silent, I will get through the remainder of this presentation here. First of all, I owe you explanation what's inside the reshape function and why we need the reshape function. And then I will give you some ideas and directions what to do next, right? Because displaying a single poorly lit, poorly colored triangle that you have to believe me it's a 3D triangle because it looks like a 2D triangle. It's not very impressive yet, okay? But you have to start from something, and this is your starting point. So why we need the reshape function? The reshape function provides some absolutely necessary setup for the scene, which is called a projection. Projection is here, so we have to set up the mode projection, load identity. You know that this is resetting all the transformation the system knows. And here you have two instructions. First one is GLU port. What happens? The GLUT calls the reshape function when it starts your application and provides you the width and height of the window in which you are supposed to display any graphics. And you have to pass over this information, the width and the height of the window, to OpenGL, so the OpenGL has this information as well. GLUT will not do it for yourself, okay? You have to do it. So you get the chance because you get these two parameters, width and height, and you can set up a viewport for OpenGL. A hint for you, you don't have to use the entire space here. From 0, 0 to WH means that your graphical display will fill in the window you are provided with entirely. Okay. You can create a window, a sub-window, or a pane, okay, a fragment of your image, so that you can, for example, write a game with shared screen, something like that. All right, and the second function here is GLU perspective. It creates the perspective projection. Perspective projection is this thing that allows you to see a 3D scene in a 2D screen. 3D scene in a 2D screen. For this, you need to know how much of the world you can see. So the first number here is 60 degrees. 60 degrees is your angle of vision, right? So you can see everything 60 degrees on your left, 60 degrees on your right, but no farther. Ratio is calculated here. That's the width divided by height of the screen. We hope that h is not 0. Okay, ratio is the aspect ratio. OpenGL just needs to know the aspect of your window. Is it panoramic or maybe square? Okay, if you don't provide the correct ratio, for example, your circles will be oval or something like that. Okay, and we also have a near and far surfaces. So anything closer than 1 unit to your camera or farther than 100 will be invisible. So all your scene should be somewhere between 1 and 100. And that's everything in the reshape function. These four functions, main, init, reshape, and render, are everything you need today to get something displaying on the screen. But of course, you can go to next steps. Okay.